All right, so here we're gonna look at this graph f of x, which again is made up of a bunch of linear components and a semicircle. We have this removable discontinuity here. We have a hole here, and notice here we have a jump, right? We have some behavior that is a little bit different on the left than on the right at x equals 4, and we're gonna see how that comes into play in our evaluation of these limits. Okay. So for A, we are interested in the limit as x approaches 0 of f of x, and the claim is that it's -2. So on my graph, what I should be seeing is that as x gets closer to 0, our function is getting closer to -2. Let's see if that's the case. So x is approaching 0, right, from the left and from the right, and we want to trace out on our graph and see what is our function doing. Okay, it looks like our function is in fact approaching that value of -2. Okay, right here, again, it doesn't matter that it's undefined, because as we trace our function, we're just getting closer and closer to that y value. I don't actually care about f of 0. Okay, so this is not the same as f of 0. Okay, these mean two different things. We're not evaluating the function at 0. We're looking at the behavior of the function as x approaches 0. All right. B says that the limit as x approaches -2 of f of x is 0. So we need to go ahead and look at what is our function doing on either side of -2. So we approach from the left and we approach from the right, but we need to trace that behavior on our function because we're interested in our y values here. So as we approach from the left, we see that our y values are getting closer to 0, and as we approach from the right, we see that they are also getting closer to 0. Again, that discontinuity here isn't an issue because we are just talking about the behavior. We're talking about as we trace this curve, what is our y value getting closer and closer to? And as we trace it from above, what is our y value getting closer and closer to? And we can see that that is the value of 0. Here we have a different sort of question, right? This asks us if x equals -2, what is the value of f of x, right? So we're gonna actually go to -2, and we wanna find the value that our function obtains. Now this whole matters, right? Because it is not filled in right here, we know that it's undefined at that point. Okay, so our y value is not going to be 0. It's actually going to be wherever that point is placed. And you can see that it's at a y value of -2. So here we can say that f of -2 is equal to -2. And hopefully you're seeing a bit of a difference between this idea of evaluation of a function right here in C and this evaluation of a limit. They are two different things. All right, 3 more examples. 6 more examples before you do some work on your own. Okay, so the limit, let's see, in D, we're looking at the limit as x approaches 4 of f of x, and I'm claiming it does not exist. So that's something we haven't seen before. We haven't seen an example of a limit not existing. It looks like if I approach x from the left, x is 4 from the left and x is 4 from the right, I'm getting two different things. So when I trace that behavior out on my graph, from the left it looks like it's approaching -2, and from the right it looks like it's approaching +2. So you can see that this behavior down towards -2 and this behavior towards +2 are not the same. Because they are not the same, we say that the limit as x approaches 4 does not exist. And we're going to continue unpacking that a little bit. Okay, we're going to actually focus on this rule right down here. Okay, this rule says that the limit of f of x, the limit as x approaches 4 of f of x cannot exist if the limit as x approaches 4 from the left does not equal the limit as x approaches 4 from the right of f of x. Okay, the only way that this exists is if this holds true. So back up on our graph, we saw that the limit, and this is question E, the limit as x approaches 4 from the left is down here at -2, whereas the limit as x approaches 4, x approaches 4 from the right is +2. So these two ideas right here, these two statements support the fact that D does not exist, that that limit does not exist. Okay, so we look at from the left and we see a value of -2. From the right, that limit has a value of +2. And since these do not match, the limit overall as x approaches 4 of f of x does not exist. Okay, so here we want to look at the limit of as x approaches 5 of f of x. Apparently it's 2, so we'll go ahead and investigate that on our graph. So, oops, I lost it. So x equals 5. We want to go ahead and approach x equals 5 from the left and x equals 5 from the right and see what is that behavior on our graph. Well, we're just looking at this line segment from the left and from the right, and we can see that that has a value of 2. Here, down here in H, we are actually evaluating our function f of 4. So we want to see what is our value that our function obtains when x equals 4. So back on our graph, we will go ahead and look at an x value of 4, and we need to decide, is it +2 or -2? My hope is that you recognize there's a hole at +2. So our value is actually -2. That's where our function is defined because this point down here is filled in. So we can say that f of 4 is -2. All right, the last one here, we're claiming that f of 0 does not exist. So let's go ahead and check out our graph. Check out our function at x equals 0 right here. If I read down to my graph, I'm seeing that there is in fact a hole, and nowhere above or below am I shown that that hole is filled in elsewhere. Okay, so because there is a hole and it's not filled in anywhere else, we can go ahead and say that f of 0 does not exist. Okay, so in both example 1 and example 2, there is a lot of differentiation between these ideas of limits, those from the left, those from the right, as well as evaluation of your function. Okay, you can see that on the next page there is a summary that I would like you to read and make note of, super helpful information that's going to help you with your practice. And then there are 2 practice problems, okay, and important information here about an upcoming quiz on Google Classroom. So at this point, I would go ahead and pause the video and work through these examples. I'll post a key that you can check on Classroom.